So with a power diagram, just like you do a signal flow diagram, a system for your audio signal, you're going to do a similar diagram for your power, okay? Because you got to have. I'm using the one off of here because they took the other one, unfortunately. So what you want is you want to be able to know where is my power coming from, and how does it get to all of the things in my sound system that need power? And how do I make sure that I'm not requiring more energy than the infrastructure is capable of providing? Okay. Here's the thing: when we're talking about like an audio signal on an XLR cable, that's such low voltage, no one really cares. There's not a whole lot of safety concerns there. But when you're talking about high voltage that actually powers equipment, if you screw that up, you can burn down buildings. Okay? And so after we burned down enough buildings, we started getting smarter about how we did electrical infrastructure inside of buildings, and now there's all of these protection mechanisms. And the main protection mechanism is some sort of fuse or circuit breaker that if you start pulling more energy than is deemed safe for whatever reason, because like when you're pulling, current is the rate that the energy is moving down the wire, and if the wire is too small for the amount of energy you're trying to pull through it, then it's going to heat up, and that can cause fire, for example. So what they do now is they build in all of these little circuit breakers that if you ever try to pull more energy through that wire than they think is safe, then that little circuit breaker is going to basically blow up. Okay? And it used to be an actual fuse, like it was a little piece of wire that was designed to quite literally blow up. But it would blow up in a very self-contained way that would not cause a fire, and it would just stop the energy from flowing through there. And then you had to go and replace that little piece of wire. Okay. Now the technology uses circuit breakers, which are just these little switches that just kind of trip and flip off to protect you. So if a circuit breaker ever trips, that usually means something is wrong. It might mean that you're just trying to pull too much energy, or it could mean that there's a wiring problem, like something is shorted out. But you want to, if it ever trips, it usually happens for a reason. And you should try to figure out what that reason is before you try to switch it back on again. Okay? Because if you never fix the problem, you switch it back on and it's just going to trip again. Okay? But that's trying to troubleshoot that is tricky and takes time. And so it's much better if you can figure out ahead of time some of those things. So how can you figure out ahead of time how to not pull more energy than you're supposed to?
Power diagram.
A power diagram. Like you do a piece of paper. My favorite thing. You draw something to help make sure that you figured this out. So here's what's happening. We tend to draw these as opposed to flowing left to right like we do with audio signal. We draw these top down. So what we try to do is at the top of the page should be sort of whatever thing is in the building that is the last thing you can touch. Okay? So you want to all these little breakers and fuses that could take out your sound system, you want to know where they are, just in case they decide to take out your sound system. So that if they do, you can go find them, and once you've solved the problem, you can reset them. So in this case, this is a power diagram for a show in the Friedman Theater. This contains the tech table, the front of house mix position, and the amp power amplifiers. Okay? And there is a panel in the Friedman. I took some pictures of it. Let me see if I can show you those. Assignment. I should have thought of that before. Come on, resync for me. Coming through, I think, eventually. All right, so once it comes in, I'll show it to you. But there's a big messy panel in there that has all these really enormous breakers on them, and the last ones that I could find there was this one that was a 400 amp breaker, which means 400 amps of current is allowed to flow through that thing. If you do any more than 400 amps for, you could probably exceed 400 amps for a millisecond or something, but if it goes on for too long, it's going to say, no, we're not doing that anymore. You're going to burn the building down. And so it's going to automatically throw that enormous switch for you and shut down your entire amp rack. Okay? So that's 400 amps. Now that amp rack, this breaker actually feeds the entire a second panel actually, and that second panel is here. This amp rack panel, and this has more breakers on it. Let's see if my photos came yet. No, not yet. So this has more breakers on it. So it's 400 amps, but then it's got a bunch of these three-way 40 amp breakers that feed different power distribution units across, both the Catawba and the Friedman, and so. If that master 400 amp breaker decides to trip, it takes out not only your show, but it takes out the show in the Catawba as well. Okay, so if you're the one that does that, it's not just you that suffers. The show down the hall, is going to be very angry with you as well. Okay, so I don't have any way of knowing what the other show is doing because I'm not involved in it. But I can say that on this 400 amp breaker, I am only worst case scenario, I'm only pulling 154.12 amps. Like if I have everything running at full blast, everyth's going on my system, I'm only bringing 154 and some change, which is well below the 400. So I've left plenty of energy available for the other show. It's unlikely that if this thing trips, it's going to be because of me. Okay. But I've just made a note here that, okay, I'm that 154. That doesn't include the other things that are fed on there, because I wish I could get this thing to sync. Why won't it sync? Maybe if I quit it and pull it back up again, it'll sync that. Because then I can show you the panel. Yes, excellent. Here we go. Okay, so here it is. So here's the main panel that drives all this. So all these enormous breakers. So this one here, that's that 400 amp breaker that feeds all the amp racks. Okay, so that breaker feeds this panel. So and this panel has a bunch of these these say 40 amps on them. That's 40 amps times 3, because it's a 3-phase breaker. Okay, which means if you wire it in such a way, you can actually get 40 amps 3 different times off that same breaker. But if any one of those legs exceeds the 40 amps, all 3 get tripped. Okay, but then there's also this 100 amp breaker that feeds a little service disconnect next to it that you can hook your own power distribution up to through some feeder cable, and that's 100 amps. So in total, there's a lot that is going off of that 400 amp service. So if each of these is actually 40 times 3, what's 40 times 3? 120. So 120 times 1, 2, 3, 4, 5 is what? 720 plus the 100 on the service disconnect.
600.
5.
So 1, 2, 3, 4, 5 times 120.
6.
600.
600 plus the 100 amp disconnect, 700.
Is it a single phase 100 amp or three phase?
3 phase.
Is the 400 amp service a 400 amp breaker earlier single or three?
I think it's 3. Yeah. So it has I think higher capacity than maybe we're thinking, but I did not wire these panels up. I'm not going to take them apart and figure out how it all goes. So I'm not really sure, but let's say it is only 400 amps single phase. It's theoretically possible to trip that breaker, even if I don't trip these. But in reality, it's probably a 3-phase breaker, which means I probably have 400 amps 3 times. And depending on how these things are wired up, maybe,
It would
have to be.
for these to be three phase.
But for the purpose of a power diagram one line, the whole point of that diagram is you really don't pay a whole lot of attention to phase in those diagrams because it gets a little dicey. But the point I'm trying to make is that that 400 amp, this 400 amp breaker ultimately feeds all of this. Okay. And these then feed other things. So it branches out, which is what I'm showing here in the diagram, right? So I'm starting here, and then that fans out to all of these other breakers that ultimately feed other breakers that ultimately feed the little things, okay? So when I get down to like this breaker down here, that's a 20 amp breaker, okay? And I've got 2 20 amp breakers pulling off of one of the 3 phases of that 40 amp breaker. So this little dotted line I'm using to just suggest that these 3 40 amp breakers are tied together. Okay, which means if any one of those 3 legs trips, all 3 of them go down. Okay, and I'm just ultimately adding all of this up and putting it on there. Now there's in that same panel, find that. So there's this other one, this little breaker here, that feeds this panel called 64PP. Well, I went and found 64PP. I believe it's this one. Okay, see it says 64PP right at the top of it. Well, that is sitting stage left on the Friedman stage. Okay, and that feeds a whole lot of circuits all around the stage and inside the theater. And including my front of house mix position, interestingly enough. So where the mix position is, it's getting its power off of that panel. And where we power the tech tables from also comes off of that panel. Okay? And so that panel is fed from this breaker, which I believe I figured out was a 150 amp breaker. Okay? Not sure if that's 1 phase or 3 phase, probably 3 phase. But I then have to figure out which circuits inside that smaller panel I'm using. So inside this panel, which of these am I using? And how much am I pulling off of them? So breaker 16, which is this one, looks like, and 15, which is that one. And those are 20 amp breakers. So that's where I'm saying 20 amps max, right? And I'm only pulling 12.5 amps off of that. Good, I'm probably not going to trip it. Okay? So now when I get into this one, so this is a surge protector. This is just like that one you're all plugged into right there. That has a breaker on it. So that one there, it's on that table where you guys are sitting, there is a 15 amp breaker on that thing. Okay, so I have that breaker drawn here, 15 amps max, and then there's a switch that you can, and those on most surge protectors, those are separate things. Some are the same, some they're separate. But electrically speaking, it makes sense to just draw them separately. So I've got a 15 amp breaker in that surge protector and a power switch before I get to any of the actual receptacles. Okay, Now, this little symbol with the circle with a single line just means a single Edison power receptacle you can plug into, okay? So I've only drawn, there's probably more than 5 on here. I've only drawn 5 of them. But then I have a little object that says, okay, this is a laptop computer. It's an IBM ThinkPad that worst case scenario is going to draw 4.5 amps, okay? And I just draw all those things, have it in there, and I say that goes through that switch. That adds up to 9.9 amps on a 15 amp breaker. I'm fine. Notice this symbol with a circle and 2 lines going through. That means that's a duplex. So that's like this one on the wall that has 2 receptacles on it. Okay? And these are standard symbols from, I think, NEC.
Question.
Yeah.
What's the circle mean?
The circle just means receptacle. It's a plug on a wall. Okay? And the number of, oh, you mean this circle?
No.
This circle.
Circle on the surge center. 5 circle.
Oh, these?
Yeah.
Yeah, those are the actual receptacles, right? The thing you plug into. Okay? And then the number of lines that go through that tell you how many of them are there. So if you've got 1 line going through it, there's 1 receptacle there. If there's 2 lines, there's 2 receptacles there.
So why on the 2 receptacle one? Because the second receptacle, it just jumps with the link bars off of the contacts with the first. So why does the line just go through the circle and not right angle into the other?
Yeah, I mean, so these are symbols that I didn't make these up. Like these came from NEC, and so in reality, maybe you would want to do that. I don't know. You could play around with this. I mean, I'm kind of trying to. If you've seen some power diagrams we've done before, they don't really look like this. I'm trying to revamp kind of how we're doing these to try to make them a little clearer what's happening, and trying to use some more standard symbols and things like that. So we may have to play around with, okay, how do we really use that symbol in a way that is meaningful? But here's another symbol. That's the symbol for a quad box, or a quad receptacle, okay? And if you have something special like this, this symbol is that with a triangle in it, means that's some kind of special power connector that's not your standard Edison. And rather than having a symbol for every single one, we're just going to do that. And then you have a little notation next to it that just says, what is this thing? It could be a power con. It could be, in this case, it's some sort of flavor of 3-pin twist lock that's on the wall there. So you would use that.
So on something like if you have say a 3-phase power dish drill, you should draw 1 and then do the 1 notation and just 5 cam connectors and then
Yeah.
continue that.
Probably, yeah. So like here's a power conditioner that's like a rack mount Surgex power conditioner. So that has a 15 amp breaker on it, and it has a switch. And what's interesting is the switch controls only some of the outlets on that thing. There are 2 outlets on that power conditioner that are unswitched, which means even if you switch off the power conditioner, those 2 ones don't go down, right? So they stay powered. Now that's where you would want to put your computer, so that you don't crash your computer every time you shut down your rack. Okay, so that's what's going. So I'm just drawing that okay, I've got a 15 amp breaker and I got a switch, but I have at least 1 receptacle that is not controlled by the switch. You see how I've drawn that? So the switch is coming between this one and this one. So all of these ones would get switched off, but this one would not.
What's that 0.5 amps?
So that is a lamp. Okay, so this
It's a lamp.
yeah. So this power conditioner actually has lights in it. Okay, and those lights, if you turn them on, they will use energy, right? In this case, I think worst case scenario, it's a 0.5 amp. So I'm just putting that in, saying, okay, that's part of it. Okay.
So why is it drawn in a line like that versus just being another device that's pulling, or why is it the front as opposed to the end?
Well, I mean, you could get in, if you wanted to get into the nitty gritty, it really probably would be another thing off of here with a switch and all of that.
Oh yeah, it does have a switch.
Right, and so you could get into that if you want to, but for purposes of this, I want to make sure that I'm counting that, right? That 0.5 amp, because if I turn those lights on, that's something, right? I just want to make sure it's accounted for in there. So yeah, I mean, we can play around with, okay, where's the best place to put that? What's the best way to introduce it? And because yeah, I mean, if that bulb breaks, it's not like it shuts down the whole power conditioner, which is what this would
It
suggest.
just makes it look like it's an inline and
Right.
all the power is running through the little bulb.
Yeah, and it's probably not, but well, it's definitely not. But yeah, I mean, you could think about that. Other ways to do that. We're playing around. This is a work in progress. This is a working draft. So we will work with this a little bit. For now, I just want you guys to draw it as I did it, because I'm not so much trying to teach you how to figure out power diagrams in this class. I'm just trying to teach you how to draw them. Okay. So you'll learn how to figure them out later. Okay. So for now, just draw this. Okay, and then we'll over the next couple of years we'll work on figuring out what they all mean. Okay, I'm just trying to talk you through what's going on
By
here.
the time we graduate, we'll have it figured out.
Yeah, we'll have it figured out. Okay. So let me. The other thing you're noticing is that I'm using just a little box to enclose things that are together in real life. Okay, I'm not trying to create big equipment blocks and everything for things. I'm just trying to say, hey, all of these are together in a panel. So if you actually look at the things that get plotted like this, and this is not plated particularly well. I think it probably would need to get broken up unless I did this on a really big piece of paper. One thing you'll notice here is the line weights. Okay, you see how the actual power signal is a thicker line weight than the text and the boxes and all of that. We're trying to draw attention to those lines, right? This is where the power is coming from. Okay, so I just want to point that out to you. So let's take a look at how this is done. So what I want you to do, the first thing I'm going to have you do for the assignment is go ahead and add to your template these symbols. Okay? So you're going to draw these symbols, and I've got these in the assignment. That way you've got them available. And what you'll notice is if I go and open up my layers here, I've got a layer for sound connection and sound equipment. So the sound equipment is the green lines, and the sound connection is the magenta lines. And notice how in my layer list I have this column is for line weight. And notice how you can define different line weights per layer. Okay? So I've set those as 0.35 millimeter. And then you have the other ones are using a default line weight. And if you go to your format menu, you can pull up that's line type. Sorry. We'll look at that in a second. Line weight. You can say, what is the default? So my default is 0.25 millimeters. So what that means that's what lines will be automatically. And then these two layers, anything drawn on these two layers would be just slightly thicker. Okay, and that just will help them pop a little bit when you plot them. And then when you draw these lines, you just want to make sure that their line weight in the property says by layer. So Kate, like you had the one where you had the few lines that were popping. That's probably because that particular line, if you looked at the line weight properties, it probably had a specific line weight called out just for that line. And so you want to make sure that you just do that as by layer. That way it'll inherit the line weight from whatever the layer that it's on is telling it to do. So easiest thing to do is if you've got errant line weights like that, is just do a select all and then change line weight to by layer for all of them. And then they'll all go into inheriting that. The other thing I want to show you is you'll notice that this line is a dashed line. You see that? How do you do a dashed line? Jason, how do you do a dashed line? So that's what line type is. So if you go to Format menu and Line Types, you got all kinds of line types here. And you can add more, and here they all are. So you just go find one that you like. so I found this one -2 that I liked. And then when I drew that line, I just went to line type and selected that dashed line type. And then it drew. So if I just do it by layer, it switches to a solid line. See that? But if I grab it and do line type -2, then it'll draw it that way. You could also have line types defined for layers, right? So that every line you draw on that layer gets that line type. You could do that if you wanted to. That's just not how I did it. So that's the basic idea here. So the assignment is to, let's review the assignment. Maybe we can check and make sure I didn't make any mistakes in here. So I want you to add the following symbols to your CAD template and then use those symbols to replicate the attached power diagram. Pay particular attention to line weights in order to emphasize the power signal. You should turn in a revised DWT template file and a DWG file containing the power diagram. So I want to see a new template file that has these symbols added to it in addition to the other symbols and other things that you've already created into your template. The whole point of the template is it has things that you're going to use over and over again, so that when you create a new file, you're not having to draw these symbols, okay? So add these symbols. There's something I need to show you about how to draw this symbol. I'll show you that in a second. And then here's the power diagram. And this is an image file. You can download this and then zoom in on it if you need to see more clearly what I did. And I'm aware that when you actually try to plot this, it's not going to make sense because it's too wide. Eventually, we'd break this up into a couple of different plates. But for now, just draw it like this as one whole thing, and we'll worry about that stuff later. So hopefully, you can kind of see how that works. So let me show you really quickly how to do that little breaker symbol. So the first thing is I'm probably going to do a little circle. Kind of like that. And maybe I will copy it. I'm not sure if the scale is right, but it's fine. We'll sort that out later. I'll put a line out like that, a line out like that. So that part you should be able to know how to draw at least that much, right? But what about the little arc that I did? Well, when I did that, I went over here to the green layer, my sound equipment layer, and there is an actual drawing tool called arc. So if you type ARC, you get arc. And it asks you, specify the start point of the arc. And I'm just going to say the center point of this circle. Second point of the arc would be the center point of the other circle. And then which direction do you want this to go? So I'm just going to sort of goof around with this until I get, this is not an architectural drawing here. So you just need an arc line. There's no specific thing to this. So once it looks about right, just click. And then what I'm going to do is use my trim tool. And I'm going to select my circles. And then I can trim out the other parts of that line. See that? And then all I got to do is take that little arc and move it up a little bit. Because you want a little bit of a gap. You don't want. And I didn't make up this symbol. This is like a NEC standard symbol for circuit breaker. Okay. So and they say do a little gap in between there. Okay. So it's the arc part. That's a tool I haven't taught you yet. So that's how you draw that one. Okay. There's a couple other ways to do it. You can do it as a big circle and then trim it. But I just wanted to make you aware of that arc. And then you can and then once you've got it like this, you can then rotate it. Because ultimately, I realized that they work better vertical in these decks. So it's easy to rotate it. You should know how to do that. and then you can put your text labels on there. So over here, let me review the symbols here. So I want an ID number up above that little arc. This would be the circuit ID. Like if I was going to go find that breaker, what label would be on it? For example, if I go up to the actual drawing, you'll see that this one, the ID just says thrust. I'm like, huh? Thrust? Why? But if you go look at the photo, that's actually what it says. That is the label on that breaker. It's not a number. It's a word. Okay. So it's just you want to put there whatever is written on the breaker in the panel. Now, how do you know that? You don't. You just have to go look at it. You have to go put eyes on this stuff. That's what I did. Yesterday I got Bill Bowles to go take me in, and I just said, I need to look at all these panels and take pictures of them real quick to just make sure that I'm putting the right labels on everything. It took me 5 minutes to just walk around and go, oh, that one, that one, that one, that one. Okay, then I went back to the office and interrogated them. Okay, so that's what the label is, and then it usually says on them, this says 40 amps. So that's what you would put then on the symbol. Oops. So you want to have, this is the maximum number of amps that can be pulled off this thing. And then this is the number of amps that I am using, worst case scenario. And again, you'll learn how to figure that out in another class. How do you figure out how many amps each piece of equipment pulls? You'll learn that later. For now, I just want you to draw that. Draw what I drew, use the information I drew, and create it that way. Okay? Any other questions about any of these symbols that you see? Everything makes sense? Okay, so you've got a little over a half hour. You could get started on this.
Question.
Yeah.
It's like a duplex stock.
I know, and I think that these first three are the ones you're going to encounter the most often, and then there'll be all kinds of weird unicorns that you'll run into all over the place. And rather than try to get into a separate symbol for all of those things, then you have to have a key and all of that. I'd rather just say, here are the ones I'm going to run into the most, and then everything else I'm just use the same symbol and have a notation saying what the heck is this thing. So. Okay. So go ahead and get started. Start trying to draw these symbols. Start trying to draw the diagram. See how far you can get, and then I'll help you if you get stuck.